Last video, we talked about decimals. Today, let's continue with percentage. So when we are using percentage, it must be a percentage of something, of a value. You cannot just say, oh, if this hat is like 15% off without the like $40 sign here, then it doesn't mean much, right? Yeah. It means something, but we don't know the actual price. Yeah. So, 15% of what? Of $40, okay, is off the chart. So we can like pay how much less then? So we can pay 40 times 15 over 100. Because 15%, 0% is like per 800. Okay. So it's like this stroke is the per, and 20 is the 20 here. And we cannot divide by zeros, so we have to like have a 1 here. So yeah, it's a per 100. Okay, so it's equivalent to multiplying the 40 times 15 over 100, and then we get that $6 is off, which means the actual price will be 40 minus 6, which is 34. Okay, so the percentage in the original setting, it has to be in a 0 to 100 cents. Or nowadays we can use like negative percentage, we can use like 150 percentage, but nobody use negative percentage yet. Yeah. So yeah, and yeah. So because 0% is none of that. So we say, 0% of $40 is $0, none of that. 100% of $40 is $40, all of that. Okay. Then between 0 and 100 is in between that can be calculated. Okay. So, what if the price increase? One more example. Maybe inflation. So the price is increased by 2%. 2% off what? 2% off the $40 of the hat. And how much is 2% of $40? It's equivalent to 40 times 2 over 100, which is $0.8 or 80 cents. So now the price will be $40.8. Okay, now we look at percentage. Is that in currency, how much is 5 cents? Okay. If we divide $1 by 100, then we get 1 cent. 5 of that, right? Exactly for 5% of $1. Okay. So because if we calculate how much is 5% of $1, so 1 times 5 by 100, then we have $0.05. And this is also known as 5 cents. Okay. Then we can get the $1 back by multiplying the 5 cents by 20. Let's say we have 25 cents. Then we have $1. Okay. So you see in here, I can rewrite the 0.05 to 5%. Because if I multiply 5% by 20, then I get 100%. Which means 5% has the numerical value of 0.05. Not necessarily dollar, can be any unit. Okay, so that's 0.05 is like 5% in terms of value. So percentage has a lot of different application, and it's very useful to present a lot of concepts. For example, you can use it in probability. We'll talk about that. So for probability, for example, you're rolling a 6 size dice. It's an ideal dice. So we have 6 outcomes. 1, 2, 3, 4, 5, 6. So 3 of them are odd numbers and 3 of them are even numbers. So the probability that we roll an odd number theoretically will be 3 out of 6. So 3 over 6 is 0.5. And because 0.5 has the same value as 50%, so we can also say there's 50% chance that we'll roll an odd number. Okay. Oh, 50% out of what, right? Because percent of something. So 50% of all the total possible outcomes is 6. Yeah. 50% of the time we will get an odd number. Yeah. And then 50% of the time we will get an even number. So we can like use percentage to present probability nicely. We can also use it in statistics. So the 6-sided die is rolled 1,000 times. The result is recorded as follows. Okay. So since you are doing science, do not believe me unless I show you a video of like rolling a die 1,000 times and then recording the results. And a more efficient way will be like getting 100 die on a tray and then roll the tray 10 times, 100 dice at the same time for 10 times, recording all the results. Okay, then I'll get this. So the probability that I'm getting a odd number with 51.2% here. Okay. This is the experimental probability. We also call this a statistics because it's based off the experimental results or observable results. Okay. So this is the chance for getting even number in this setting. Okay, you can see they're very close to the theoretical probability. Yeah. So percentage can also be used in calculating interest. So for example, $2,000 is borrowed from bank. We'll be starting a small business. So, and the bank is charging 5% interest per year, and we have to pay back 2 years later. Okay. So how to calculate the interest charge 2 years later? So since it didn't say it's compound interest, it didn't say where when do we calculate it? It's like every 6 months, every 1 year, every 2 years. It didn't say that. So which means it's simple interest. Okay. So interest charge per year will be equals to $2,000 times 5%. So the interest is based off how much is borrowed. Okay, 5% off the total amount borrowed. And it's 2,000 times 500. So $100 will be charged, okay, per year. So after 2 years, the total interest will be $200. So during the payback, the small business will have to pay back $2,200 to the bank. Okay. As a total. 2,000 will be the original amount borrowed. 200 will be the interest charged. Oh, what if it's a compound interest? So 2,000 is also borrowed from a bank. A 5% interest rate is still charged annually, however calculated every 6 months. So when we see this, it means it's a compound interest. Or it says it's compound interest. But if we don't have this here, then with this we still know that it is compound interest. Okay. So what's the total amount to pay back after 2 years? How to calculate this? So for the first 6 months, the total amount owed to the bank will be $2,000, the original amount, times the interest. This part is the interest. So 2,000 times how many? 5 over 2%. This is 2.5%. So why 5/2? So because the 5% interest rate is charged per annum or annually, 1 year, but it's calculated every 6 months. So this is a ratio. We will find the interest for the 6 months based off this ratio. So the interest rate will, let's say, is X%. Will be a portion of the 5%. But how much portion? This is the ratio. How much portion? Oh, 6 months. In 12 months. Because a year is 12 months. So X should satisfy this ratio. These two ratios are the same ratio. So by inspection, X is 2.5. It's 2.5%. And because 6 is half of 12, so X will be half of 5. And that's why it is 5/2% here. Or we can do 5% times 6/12. And we get that the total amount will be the original amount plus the interest. So this is factorization. This 2000 times 1 is this 2000. This 2000 times 2.5% with this interest, we'll get a total amount of $2,050. That's the total amount owned after 6 months. So after 12 months, how about that? Oh, then when calculating, now the total amount owned is 2,050 because it's calculated. So this is the total amount. And the interest will be based off this amount. The interest calculated will be based off 2,050 instead of 2,000. Okay. So then we calculate 2,050 times 1 plus 2.5% bracket. Similar to what we did here, but now 2,000 has become 2,050. Oh, and because of the previous calculation, I know that this 2,050 can be broken down into this expression. Okay. These two are equivalent. And from in these, oh, we have two same factor. So we can let the n is equals to 1 plus 2.5%. So this will be n times n. Okay. So, and then n times n is equals to n squared. Okay, this is n squared. Okay. Then after calculation, we can use the calculator. Then we get this amount, this total amount owned after 12 months. Using the same method. Now this is the new amount owned. So we base off this to calculate the interest. So then now we have this amount is is owned to the bank. So same calculation. This 2,101.25 is broken down into this expression because we did this earlier. And then using in this is n squared, this is n squared times n is n cubed, okay, or n to the power of 3. So in this pattern, we can see that we don't have to do this every time because we see that every time we calculate once, the indice above the bracket or the factor will be 1 here, 2 here, 3 here, and 4 should be 4 here then. So out of 24 months is 2000 times 1 plus 2.5% bracket to the power of 4. And we calculate 4 times because 24 months has 4 6 months in it. From the question, is calculated every 6 months. In 2 years, it will be calculated 4 times. We know that it's because 24 divided by 6 is 4. So then we do the calculation, we find total amount owed to the bank will be 2,207 point. So the bank may round up to the nearest cents then. So percentage has lots of applications. Then like the discount, and then the inflation, the interest. So it can also be related to decimals. So it's like here, you see that 5% has same value, numerical value as 0.05. And it's a way to present something, and it's nothing new. It's another way to say decimal place, you can say. Or can you also look at it as like a per 100. All of these are valid interpretation of the percentage. So see you in the tutorial.